If anybody does do a talk, get a hype man. You need him. This is my guy down here. He's available for hire. So, observability is indeed too expensive. I made the title really plain and straightforward because the pain is really real right now. I don't know if anyone's done a free trial on any of the major observability SaaS vendors, but I have never heard anybody say, wow, this invoice is so low. It just never happens. It doesn't exist. Unfortunately, there's a real trend here. So, I'm Chris. I have been a software engineer for about 10 years now across Java. I did some React engineering, some Golang. That was a weird time. And then I was an SRE for 5 years on Kubernetes platforms. And now I am the developer advocate at CoreLogix. My job really is pretty sweet, actually. I come to these conferences. I talk about observability. I talk to people, try and understand where the pain points are. I spend a lot of time at the booth talking to people. I don't work in sales, so I don't have to worry about selling to people. I can just kind of find out what's going on. And the big thing that everybody says to me, every single conference, 50% of the people is, it's so freaking expensive. Why is it so expensive? CoreLogix has kind of been on a bit of a journey with that. So we are CoreLogix. We're a SaaS observability company. The thing that we do, we have a bunch of really great, really nice features. A few years ago, we decided to re-platform our architecture so that we were able to kind of make decisions in stream. So it's a streaming-based architecture. It enables us to make decisions really early, before data storage, before any expensive processes on our side. What that means is because we can make these really quick, really early decisions, we can save a bunch of money ourselves, and because we save the money, everybody else saves the money as well. So the idea is that over the years, we've begun to save customers enormous amounts of money with some of the features I'll talk about later on. And this talk is half a journey of how we arrived at the features we arrived at based on what we observed in observability data. And the second part is some of the features themselves and some of the architectural patterns that you can employ and avoid for your own homegrown solutions if you're running OpenSearch or Grafana or whatever it is that you're using, some of the tricks you can do and some of the really common things you definitely should avoid because they're very expensive. So, yeah, that's a breakdown of the talk, why it's becoming expensive, what we can do as engineers, and then what we can do about it as consumers as well. So because a lot of us are using SaaS observability platforms, you can't change the engineering of the platform itself. You're just a customer of it. So what are the kind of questions you can ask to make sure that you're getting a good deal, make sure that the features exist that you need to do cost optimization in a real way, not just delete a dashboard and save $3 a month kind of deal. I'm talking about thousands, large percentages of your observability costs. So essentially what happened was we started to realize that observability is quite expensive. Most of the common sort of estimations is that observability will cost between 7 and 10% of your overall cloud budget. You see that a lot. However, there's a Honeycomb blog, I just read this one, that it can be up to 30% is normal. Honeycomb, really authoritative charity major, is a very intelligent person. 30% is really high. To give you an analogy, if you built a factory for $1 million and you said, wait, I need some cameras in here, and they went, yeah, that'll be $300,000, you would be upset. You would not be happy about that outcome. And that's essentially what we're talking about, right? It's CCTV for your software, and it's a third of the cost. That's insane. Even 10% is high, by the way. Even 10% is high. $100,000, for $1 million cloud spend is a lot. So some of the things are driving this. One, we thought microservices would be a good idea. Still, some of you can see the wrinkles here and the gray hairs. This is caused by that. Many nights of wondering which payment service v7.9 is broken. It's a whole experience. And actually, by the way, it's all backed by monoliths. Like all these big, amazing microservices architectures, 9 times out of 10, there's a 25-year-old monolith that's powering the company behind it all anyway. So. The next thing is things like chaos engineering and practices. So when I was an SRE, trying to explain to business people that I am on purpose trying to break the database in a controlled way was a fun conversation to have. But essentially, as engineers now, we're actively trying to break things because we're trying to do true disaster recovery, true resilience to failure. But that adds all these new failure modes and all these new complexities into your data because am I failing over the database at the same time as I'm running a deployment of a new piece of software, patching a Kubernetes node and changing my EKS version from 22 to 23 or whatever? All of these things create all these really complex failure modes. And this, not just the addition of a new thing, but the interaction between all the things that are happening at the same time, really complicated, drives more data. And finally, infrastructure is becoming very ephemeral. So it's not just about that. You can now have servers that last for 10 seconds, 20 seconds, and then they're just gone. And that they've done their job. That's very optimal. Again, servers just randomly dropping in and out. As much as we like to claim that Kubernetes can handle that perfectly, it handles it well, I would say, but there are so many edge cases where things can go wrong that it, again, adds failure modes. All of this has driven new services to monitor them. Those new services have driven new data, and the data volume has just exploded. So when I talk about cost, and I talk about large volumes of data, there's kind of a natural conclusion that you draw. We need less data. We just need to reduce the amount of data that we've got. The problem is that you kind of need the data. Data exists for a reason. And so at CorrelLogix, we kind of thought, well, what are the things that are driving this data? How do people use this data? What are the reasons for the actual explosion in cost? And can we do anything about that? And so we actually started to investigate how people are actually using data. CorrelLogix has thousands of customers. We regularly run these anonymized meta-analyses. So I kind of look at how documents are being accessed, how often metrics are being queried, how long those queries take to run, how far in time those queries run, and so on. And we came up with some pretty interesting stuff that we did not expect, but it completely changed our product backlog. It completely changed how we look at the data and everything in it. So number one, 99% of your index data is never searched. Something of a dangerous thing to say as a company that makes money from people storing their data, but it's true. It's just a fact. You index the data, and indexing, by the way, is the most expensive thing you'll do. Indexing your data is by far the most expensive thing out of any of the processes. It's the most expensive in terms of computation, retention, everything. It's the fastest storage modes, everything. So 99% of that cost is essentially useless. And that's not to say it doesn't drive dashboards or create metrics, that kind of thing, or alarms, but it's never searched actively, which is crazy. The next thing, 95% of callouts come from the same 5 errors. So that's over the time span of 6 months. The same 5 errors just recur. But the average number of alerts that teams have, not just in the CorrelLogix platform, actually they have less in the CorrelLogix platform, don't need as many. In other platforms and in homegrown solutions, you're talking about hundreds of alerts. It's very, very normal. With alerting definitions as code now and alerts being defined in like Terraform loops to create these massive things, easily have thousands of alerts. But the same 5 errors are causing 95% of them. And on some platforms that charge by alert, that is a lot of money for not a lot of coverage, or the illusion of coverage. 99.9% of queries don't pass 7 days. Does anyone want to guess what the average retention period for logs is? I've spoken to people all over the place. This is surveying thousands of companies. Does anyone want to hazard a guess at how long the average retention period is? 6 months endless. And yeah, they just burn money. 6 months is very high. You've ruined the whole thing now. So, but it's 4 weeks. So 4 weeks of indexed high performance logs and traces actually, and yet that's only useful like 100th of the time, or 1,000th of the time. The rest of the time you query within a week. So again, you're holding data. That's a 75% addition to your cost on average for no reason. So all of this is to say that it's not that we have too much data, it's that we're using the data really, really inefficiently, which is beautifully highlighted by this particular statistic. 30% of data on average not only is never queried, it's never used. You ingest it, you pay for it, and then you never touch it ever again. It's like, I don't know, buying an Xbox and leaving it in the box, just looking at it every now and then. It's the same kind of thing. We don't do this in other industries. It's very rare that we buy or we rent virtual machines, EC2 instances, and that kind of thing. It's very rare that we do that and then never use them. Or if we do, it's a total accident. And it's because the visibility of this data is really clear. You can just go into, for example, in AWS, you can just view EC2 and see that nothing's being used. CPU is 0, memory is very flat. These are useless, let's get rid of them. If you have volume storage in AWS, for example, you can go and see that it's unattached from any server, let's get rid of it. But it's very, very difficult to know what data you are and aren't using in this space. And that's like the real nub of the challenge. So all of this has driven some findings and some outcomes in the sort of observability space here at CorrelLogix, not just how we build our own solutions, but also when I come to events like this and I talk to people and they tell me about their architectures, there are some really common things that people are doing that are actually driving costs a lot more, even though they are like the de facto standard things to do. So one thing, nobody ever creates usage statistics. So nobody actually knows how they use their observability data. There's just a general idea. We just take logs, we put them here. We take metrics, we put them here. We take some traces, we put them here. We use them for a bit, and then we delete them, or we archive them. But we never actually build usage statistics. These are just some examples of things you can do. Prometheus will actually give you a log that tells you how often queries are running, how long those queries took, and so on. If you take that, you ironically index it, and then you can query. You can look at how many times a certain query in Prometheus is running, how often a particular metric is being invoked, and so on. OpenSearch has slow query logs, so you can find out which queries are actually causing massive sort of slowdowns that impact your resources. However, what you can do is you can turn the definition of a slow query into 0 seconds, and it will log everything, which obviously has performance implications, so do that very carefully. But if you do that on one node, for example, and you sample that for maybe 10 minutes and then turn it back off, you have a pretty robust insight into how your data is being used. So all of these things that you can do with open source solutions straight away. So with no extra cost. It's not a lot of data, it's very easy. So whatever solution you're using, they almost always have some kind of mechanism for at least visualizing the really slow stuff or the really painful stuff, and often actually just have full usage queries that you can do. So look at that to start with, because once you have a map of how you're using your data, then you can really understand that. This pattern, I'm going to stick my hand up and say I've implemented this in about 8 different companies before I had my sort of observability revelation. So essentially the pattern is you ingest, we'll use logs as an example. You ingest some logs, we stick it in OpenSearch, that'll do. We hold it there for 2 weeks, and then we go, oh, I'm going to be sophisticated. I'm going to move it down to sort of block storage or whatever, slightly slower. Then after maybe another couple of weeks, I'll put it in S3. And we all go, wow, that's really clever, cool. And then you realize that some of the previous statistics, 99% of your data is never searched, but it's spending weeks in searchable storage. It's really expensive. When you have a large volume of data, that's quite painful. And also, the real issue is that this stuff, the SSDs, are really expensive. Like at scale, they're really, really expensive. Indexes themselves, the actual indexes, not just the data, but the metadata about your data, is really expensive at large volume. The clusters necessary to handle large volumes of data are really, really expensive. All of this is just a constant spiraling of cost going on all the time. So we pat ourselves in the back for this pattern, but I can say that I'm never going to implement this ever again. And the reason for it is because, as we've said, not all of your logs are going to be searched. Not all of your logs are going to drive dashboards. Not all of your logs are going to drive alerts. Some of your logs are just going to be ingested and ignored for the rest of their remaining lives. It's just that's simply a fact. So we should get away from this pattern. Step 1 is not all data is the same. So if we have 3 different applications and they're being used in different ways, don't waste time indexing that data. Like find a way of routing it off straight to, for example, S3, and just hold on to it. Delete it if you don't use it, even better, Or S3 is a nice safe option, for example, in the AWS use case. S3 is a nice safe option because it's cheap and it's like 0.002 cents per gigabyte, so really, really cheap. But really importantly, it's all about look at your data, see how you're using it, and use the appropriate storage for the appropriate challenge. Okay, and that's just the idea, is just be really use case driven about your data. This is the first piece of advice. The second thing would be make a screen that's, okay, yeah. This is just an animation, don't worry about it, guys. So the AWS Athena is a really nice tool. Rather than, okay, I want to query this data, think about how often you query this data. So, okay, I have to query my data once every minute. That should probably be in SSDs. That's pretty frequent. I use this all the time. This is essential operational data. It should probably be in SSDs. I query it once every 6 months because someone from HR told me I have to. Probably shouldn't be in SSDs. Just leave it out. Leave it alone. It's fine. Put it straight into S3. Don't even bother moving it to SSDs. Just write an Athena query. Athena's great. It can run against CSVs. It can run against Parquet formats. You can decide how you want to store it. But the really important thing is that Athena is really flexible. If you use it infrequently, it's not very expensive. If you use it a lot, it becomes very expensive. So once again, just to go back a step, be use case driven. If it's frequently used, don't start querying it in Athena. You're going to spend a lot of money. But you don't have to index everything. That's like the architectural rule here. Because indexing is so expensive, it's the most expensive thing you're going to do. Try and avoid it, and you can. And you don't have to compress. You don't have to heavily compress the data. You don't have to delete the data. You can just ingest it and query it infrequently in an indexless way. So really, really powerful, really easy to do. Athena will automatically index It'll automatically generate metadata tables about the data that's in your S3 bucket. AWS does that out of the box. GCP has BigQuery as an example. So whatever cloud provider you're using, have a think about this, especially for your logs. The logs are the things that tend to become very verbose, very fast. Same with traces as well. Then optimize your demand. So if you never ever look at your debug logs, stop sending them. That's easy. You just saved a whole bunch of money. Debug logs represent a huge, huge cost volume for a few reasons. One, there's lots of them, because there's usually a lot going on, technically. And secondly, the actual documents themselves are huge, because they have a lot of metadata, and they need a lot of metadata because it's a technical piece of information, which is great, but it will cost you some money to index and hold all that data. Even putting it in something cheap like S3, you can keep it if you want, but realistically, when have you ever looked at the debug logs from an application for 2 months ago? It doesn't happen that often. If it does happen quite often in your company, put it in S3 if you query it infrequently. Again, be really use case driven. But what my point here is that you don't have to send everything if you don't want. It's kind of up to you. So block, and then if you can't block, think about the storage direction, think about the place where it's going to be, and then think about whether it ever needs to be indexed in the first place. So what you can do is some of those debug logs, for example, is you go, well, do I actually need the log? Do I actually need the original piece of information, the really expensive, really heavyweight piece of information that I have to index and query? Can I just turn it into, for example, a time series metric? Time series metrics are really cheap. You can hold onto them for a very, very long time. They're not very difficult and complex to query, and you can perform a lot of calculations with them. Really flexible, really easy to use. The beauty of that is you'll save a whole bunch of money by transforming into metrics. You can retain them for a really long time. It's not complicated to do. There's a bunch of open source tools that will export JSON documents from OpenSearch, transform them into Prometheus metrics, and remove them from your OpenSearch cluster. So that way, you get the retention. You get the retention, you get the sort of long form, you get the queryability, the access, the really quick speed, because Prometheus, as we know, is awesome. And Prometheus-based metrics are really cool. OpenTelemetry is a really nice option as well, if that's what you're using. But you don't pay the cost, because you keep the data that you need. So it's all about be selective with what you decide to ingest in the first place, be clever about the direction and the destination for the ingestion, and then be clever about the form in which you decide to hold your data. And these are the kinds of patterns that I don't see very often happening in companies, and some of them are difficult to implement. I won't lie to you, this is going to be a bit of a journey if some of you decide to go down it yourself, but it's doable and it will save you a whole bunch of money, especially if you have a large volume of telemetry data. So if you come away with a single phrase, anytime you hear the word indexing of your telemetry data, just stop and think, do we really, really need to do this? Be very cautious about it. Treat it like a wild animal that you've cornered. Just stay away, okay, don't kill me. That's indexing, okay? Be really, really nervous around it. Be cheap, be difficult, whatever word you want to use, but be cautious around indexing, and you will almost certainly save a whole bunch of money just by doing that. Just that one design principle, that one approach. Just be really cautious about what you decide to index. And by index, I mean the high performance kind, not the sort of just keep track of some fields over a long period of time. So for example, what OpenSearch does would be what I would describe as indexing there. This is the thing that will kill you in the end in terms of cost. This is the thing that will drive up your cost. Almost everything else is kind of, it's by the by. Bearing in mind, indexing isn't just for logs. Traces and metrics can be indexed as well. So just think about the storage, think about the solutions that you're using. Not everything needs to be driven around in a Ferrari and needs the speed of a Ferrari, okay? Sometimes a nice, what's a German car? A Volkswagen will do just fine, yeah. So the point, one of the final points I want to make here is quite simply, if you're not building yourself, so if you're if you're looking at a SaaS vendor and you're kind of interested in what is the question I should be asking these SaaS vendors? What is the thing that I really should be looking for, okay? It's this. This is the one that kills people. Actually, this is the one that really, really kills companies when you ask them, because they don't really have an answer for it, except maybe one company. But the idea is this. What tools do you offer for customers to optimize their costs? Not what techniques are available, not what can I do to optimize my costs. What tools do you offer specifically? What engineering investment have you done as a company to make it possible for me to save some money with you? That's the question. That's the killer. Because most companies will say, well, cost optimization is great in our platform. What you do is you delete the resources you're not using. Oh, thank you. Great. High fives, everyone. That's useless. What, for example, have they built any visualization tools to help you know what tools you're not using or what data you're not using? Have they built you any information to tell you, okay, you can shave this off, you can stop this application's costing you a lot of money. Have they done anything specific in their product to make sure that you can save some money? What this will tell you about the company is that their bottom line isn't based on ripping you off. It's based on you getting good usage out of the platform. So this is this is, in my opinion, the killer question. I was asking people this a few years ago, and there were some pretty interesting answers. It doesn't come up very often. It's not a question that salespeople are prepared for. It's a question that they don't really expect. They expect, can you use AI to track my logs? Can you know, how many time series metrics can I store in one parallel time or whatever, all the rest of it. They expect those questions and they have those on a piece of paper. They do not have the answer to this question. And this question will give you a real insight into what those companies are about. So, quick thing about CoreLogic specifically. This is actually the aforementioned tool to help you cost optimize. So what we do is we enable you to put your data into 3 different tracks: frequent search, monitoring, and compliance. The idea is really straightforward. If you access your data frequently, put it in frequent search. If you access your data irregularly, or more importantly, you just want to transform it to metrics, drive some alarms, teach machine learning models, that kind of thing, visualize on dashboards, put it in monitoring. And finally, if you just have to hold that data for a regulatory reason, just put it in compliance, store it in cloud storage in your own account, so you're not even paying us for the retention costs. You just pay the bare bottom cloud hosting costs. And that's it. And the idea, people save literally 40–50% of their observability costs by just using this tool. And the tool is horizontal as well as vertical. You can say this entire application, compliance. It's just putting out historical information. You can say debug logs from every single one of my application, monitoring. And you think we talked about the volume of debug logs. Debug logs typically make up about 25% of your overall log volume. That's a quarter of your logs have just disappeared, and therefore a quarter of your log bill is just removed by 68%. So this took us a long time to build, but it's really cool. It's really, really powerful, and this is like the thing, in my opinion, that when we show this to customers, it really speaks to them, especially around that cost issue. The second thing that we offer is indexless direct archive query. I mentioned that the archive is held in cloud storage in your own cloud account, not held by us. So we're not basically putting something in, for example, S3, and then charging you a markup for it. You just pay the retention in S3 in your own account. And then you don't even have to index it. You can just go into the CoreLogic's logs screen, this button here, archive. You click that, you are now in what we call archive mode, at which point you are issuing direct queries to your CoreLogic's account. You can see our own syntax is called data prime. This is really nice for analytics. You can run analytics across millions and millions of documents. This thing will run 5 times faster than Athena, up to 5 times faster than Athena in some use cases. And you can also use Lucene as well if you're more familiar with the sort of Lucene query syntax. But the idea here is really straightforward. We looked at how people are using data. We found that there's some really key problems. 1, you shouldn't have to index everything. And 2, you don't have to put everything in the same high-performance place. Or you don't have to treat all of your data equally. And yeah, we built some features to address those problems directly, and it's working. It's solving problems for people, especially around cost. So that's the whole talk. That's the whole idea. But the principle here is, like I say, index cautiously, treat your data as a use case-based approach. So how are people going to consume this data? How often do people query this data? How big is this data? Is it really worth the cost? Make that trade-off. Remember, you have multiple storage options, multiple processing options, and you can transform the data before you store it. If you just need one number out of that log, you don't need a log, you need a metric. If you just need a count of that log and that's all you ever do, you don't need the log, you need a metric. You know? So they're just some of the architectural, some of the general buying principles, and some of the general design principles and data management principles that will cut the cost of whether it's homegrown, whether you go with a SaaS provider, asking that question, all about how efficient, what tools do they have that actually will help to save some money? What have they built? What investment have they made to make sure that you can save some money on their platform? Look for that. And yeah, finally, how CoreLogic sort of fits into that problem and how we're the only ones right now that are tackling this problem head on. We're not turning away from it. We're not doing a kind of half, oh, here's some nice documentation on how to delete the dashboard. We're making a real investment, a real effort as a company to make sure that people get good use out of the platform. And top all that off, we don't really like vendor lock-in either. So we actually strongly encourage, if we do onboarding for you, which we do for free, we'll use OpenTelemetry. We'll encourage you to use things like Prometheus so that you're not locked into it. The best vendor lock-in is that we will cut your costs by 30 to 70%. It doesn't get much better than that. So that is the whole talk. That's the whole topic. Hopefully you guys have had some ideas here to go away and apply to your own infrastructure. And if there are any questions, I'd love to hear them. But yeah, thank you very much.
All right, I don't know if you can get the Slido up on the screen, but if we don't, I have it up on my little screen here in front of me. We have one little question, and you can ask the questions just as you did maybe in the main room before. There you go. Do you have any thoughts about costs arising out of high cardinality of index data and how to bring down high cardinality in the metrics?
Yeah, lower the bloody cardinality. It sounds really simple, but the amount of people that I've spoken to, and they have like metrics with like bloody 200 different labels on, and they query on 3 of them. Like, why? Why? Again, this problem almost always evaporates when you get some usage statistics and you understand how people are actually querying the data. It literally just disappears almost instantly. Most of this is usually down to overcaution by people, actually. It's usually down to, well, what if we need to query it by the continent that the user was from before they were in the current continent they're in? You know, it's just be a little more cautious. What I would say, if you can generate custom metrics or use recording rules in your application to generate your own metrics, do that and drop the old ones, or split your metrics up into multiple different time series. It's probably cheaper, and it's definitely better computationally to have multiple time series with very low cardinality than it is to have one time series with an absolute massive volume of cardinality. So there's some of the things you can do there, split your metrics up, but really usage stats. Usage stats will probably kill that problem for you.
Excellent. Wait, give me a second. We have 2 more.
Okay.
Let's see if they're for this room, because that's also a thing. How do you know what to filter out? Or are there any keywords which you should always use?
One is the Java heap. If you just look for the word heap in an Elasticsearch cluster, you will almost certainly find a volume of logs that don't need to be there. That's like a golden rule. Look, you guys know your infrastructure. You know what your tool set is. And I guarantee, I saw some nods. I know there are some people in this room now who know they've got some noisy applications that are wasting money. I know this to be true. I can see the smiles. So I can't tell you about the internals of your architecture. I can tell you that there is somebody in your company that knows and hates how noisy some of your applications are. So those are the keywords to look for. Look for the angriest person in the room, find them and ask them what the keywords are. They'll be able to help you, for sure.
Excellent. We'll do 2 more, and then we'll have an early break, which I think people will be thankful for.
Yeah.
Which one should we do first? Okay, so shouldn't the first step be to reduce the logs that you don't need?
How do you know which logs you don't need? Step 1 is get the usage statistics, and then you get rid of the ones that you don't need, for sure. By the way, everyone thinks about logs because logs are typically the most expensive. Traces cost people a lot of money. Spans and traces cost people a lot of money. So I wouldn't neglect those. If you're ingesting them, definitely have a look at both logs and traces. It's really important that you tackle both, because every single application that you add is a potential n number of connections to all your other applications, and that's a potentially complex number of traces that are increased. So yeah, I would think about definitely usage statistics. But yeah, I mean, yeah, if you want to tackle the logs first, again, if logs are the big problem in your organization, go for it. Less data is good if and only if you've done the usage statistics to guarantee that you're not getting rid of data that you need, because the extra $1,000 that some logs are going to cost you is a lot less than the prolonged outage that happens because you haven't got the data you need to solve the problem that you're trying to solve. So just be aware of that.
I am actually very happy that we turned moderation on, because I think there's a question from Hype Man, how do I sign up? But we're not going to cover that one. What do you think about using solutions that by design index less, like Victoria metrics or Loki for logs? Great,
really cool. Loki's really cool, Victoria metrics cool. We use Victoria metrics internally at Coralogics. However, the only thing I will say with Loki is you have to know how you're going to use your data really quite well. So you have to know what queries you intend to run. You have to have specific, very clear vision for how you're going to use, for example, your logs. If you don't have that, what will happen with Loki is that your indexes, because of the way it's structured, you're going to run into very slow queries all of a sudden. You're trying to use more wider and more general use cases. So just be aware of that, something to keep mindful of. They're awesome if you know specifically what you're going to do. And they offer potential for serious cost optimization, actually, if you know exactly how you're going to use your data. If you don't, then you're going to run into slow queries, usability issues. And those slow queries, again, you know when they're going to happen at 3 in the morning when you're trying to debug a serious outage. So it's just something to be mindful of. There is a clear trade-off there to be aware of.
Well, excellent, and thank you so much for your talk. Thank you for being the first audience in this room. We're going to go for a little break, and I'll see you after the break, hopefully.
And thank you very much to the hype man down here, Fran. My guy.